Hello class, today we're going to go over Unit 7, Lesson number 3, 7.3 double angle formulas. So these are the last set of new formulas that we are going to deal with this unit. So we're going to add these to our formula sheet, and obviously you can still use these during assessments. Alright, so just to review, before we go into the double angle formulas, let's review the compound angle formulas that we learned in the last lesson. So those are also known as the addition and subtraction formulas. So let's remember that cosine A plus B. Okay, so for that rule, remember the coses stay together and then the sine switches. For sine, the sine and cos are together and then the sine stays the same. And then for tan, the numerator has the plus sign in between and a negative on the bottom. Okay. So cos A, cos B minus sine A, sine B. And then the next one's sine A, cos B plus cos A, sine B. And then tan A plus tan B divided by 1 minus tan A times tan B. And then our subtraction formulas follow those same patterns. But obviously the sign is switched. So for here it had cos A minus B, so between these two terms we've got the plus. Sine A minus B, the sign is maintained here, so a minus, and then the minus here, and the plus down here. Okay, some other identities that will help us when coming up with our new formulas today, along with these two sets of formulas, is the Pythagorean identity. Okay, and so remember that states that sine squared theta plus cos squared theta equals 1. Okay, something else I want to review at the side here, okay, as a side note. So remember in trigonometry, I know this looks kind of weird, right? Sine squared theta. So when it's written like this, or sine, cos, or tan looking like this, what it really means is that it's taking the value of sine theta altogether and squaring it. Okay, so whenever you see something like this, it means this. It does not mean sine theta squared. Okay, so if it's written like this, then that makes it seem like the theta gets squared first, and then you take sine of that. So this is not good. Okay. So it's sine theta, that value, all squared. All right, so with Pythagorean identity, there's always two other ways that we can rearrange the formula to get two other identities. Okay, so our first one would be if we were to isolate cos squared theta, and then we'd bring sine squared theta over to the other side and make it negative. So this is another variation of Pythagorean identity. So cos squared theta equals 1 minus sine squared theta. Our next one is going to be where we leave the sine squared theta on one side and we bring the cos squared theta over. So that will give us sine squared theta equals 1 minus cos squared theta. Okay, so we have to be able to recognize all three of these. Okay? All mean the same thing. Alright, so now I just want you guys thinking, if I gave you these two formulas, it says what is the difference between y equals 2 sine theta and y equals sine 2 theta? Okay, so some students will still look at this and later on, you know, their eyes will just trick them and they'll think that this is the same thing. So let's remember, two expressions are equivalent if they produce the same graph. So let's go over carefully what this means in terms of transformations. So let's work with the green. So we've got 2 sine theta. So in this case here, we have an A value of 2, okay, and a K value of 1. Okay, so that means the period for this one has been unchanged, right? So for here, that means the period is 2 pi divided by 1, so the period is still just 2 pi. However, we have an amplitude of 2 now, so that just means it's been vertically stretched by a factor of 2. With the purple equation here, right, we've got y equals sine 2 theta. We've got values here of a equals 1, So this one isn't vertically stretched like this one is. But here we have a k value of 2. So the k value of 2 means that it has been horizontally compressed by a factor of 1/2. So that means the period, right, we do 2 pi divided by k, so 2 pi divided by 2, that means the period has been cut in half from its original, from 2 pi to pi. So when we graph these, let's do little sketches here. So here I've drawn in blue is regular sine. Okay. In green, remember, it should have the same period. However, it should meet, it should have a max and min that are higher than that of the original. So because our amplitude here is 2, that means its max is 2, and then its minimum is -2 because we haven't deviated from our equation of axis of y equals 0. However, the purple graph, it wasn't vertically stretched, so notice that the purple graph still meets its max and min of 1 and -1. However, we took this blue graph and pretend you're taking your finger here and squishing it in. We horizontally compressed it so that it finishes one cycle in pi, in the amount of pi. So that means, right, it's going to hit its key points in smaller intervals, here, 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 and here. So looking at these two, even though visually they may look the same, or you may think that you can, students sometimes think that they can pull the 2 out of theta and bring it in front. Okay, you cannot do that. Okay, the 2 is a package deal. Okay, so the 2 theta is a package deal, and the 2 cannot be factored out. Okay, so we can see they're not the same thing, so we can conclude, therefore, that 2 sine theta is not equivalent to sine 2 theta. What this means here is that you're actually taking some given theta value and multiplying it by 2. So you're doubling the angle. Okay, so hence why it's called, so any trig function with a principal angle of 2 theta, so meaning the input is 2 theta, is referred to as the double angle formula. Right, you're plugging in a value for theta, multiplying it by 2. All right, so let's go over, there are ways that we can avoid using 2 theta by rewriting it in other ways. All right, so let's start with y equals sine 2 theta. Remember, you will never be asked to recreate these proofs. So what we're going through is kind of mathematical proofs of how they become different forms. But it's really good to make sure you understand the steps, because this is good practice for when we have to rearrange and modify and work with trig identities in another lesson. Okay, so it's good work for your problem solving in your mind. Okay, so y equals sine 2 theta. This is technically, I could rewrite 2 theta, right? So I'm taking 2 theta and I'm rewriting it as theta plus theta. Okay, that's another way of writing it. That would simplify to 2 theta again. Okay, so I'm taking that, and let's see what happens there. So when I write it as sine theta plus theta, I'm thinking to myself, that looks like sine A plus B, right, from the previous unit, or sorry, from the previous lesson. In this case, though, the A would be theta and the B would be theta, right, because they're the same thing. All right, so let's plug that into our sine A plus B formula. Okay, and again, you can refer to the top of the page here. Okay, so we're just plugging it into this blue equation, or sorry, the green equation here for sine. So that's going to be sine theta cos theta plus cos theta sine theta. Okay. What you should know is when you're multiplying two terms, it does not matter which one goes first. So essentially sine theta cos theta and cos theta sine theta is the exact same term. Okay. So if I collect like terms, that's actually equal to 2 sets of sine theta cos theta. And there we go. That is the formula for sine 2 theta. The reason why this will be beneficial is you're going to see later on it might be easier to work with a singular theta as opposed to a 2 theta. So this is why knowing this is important. We can make it something that's difficult for us into something that's simple for us. All right, and now let's move on to the next page. Cos 2 theta. So notice cos 2 theta has a lot of space, and I have numbers 1, 2, and 3. cos 2 theta is unique because there are 3 different versions of it. So we can actually manipulate it into looking like 3 different things. So let's start with the first version. So just like before, I'm going to write 2 theta as theta plus theta and see what happens. So again, like in the previous example, this looks like cos A plus B, where A is theta and B is theta. So now refer back to the previous page, and our formula for cos A plus B would be cos theta times cos theta minus sine theta times sine theta. So remember, instead of writing cos theta all in brackets squared, we write it like this. Oops. So cos theta times cos theta is just cos squared theta. And then minus sine theta times sine theta is just minus sine squared theta. So I want you to highlight this. This is version number 1. Okay? Again, we like it because it removed the 2 as the k value. And then obviously the k value here is an imaginary 1. Okay? So these 2 expressions are equivalent. If we were to graph this side and this side, they would overlap. Okay, let's do our next version. So our next version, it builds off this line. Okay, so we're going to follow here in red. So our next step is that we are going to apply the Pythagorean identity. Okay, so I'll write that here. So we are applying the Pythagorean identity, Pi. Okay, so I'm going to replace sine squared theta with the version of Pythagorean identity that says it's equivalent to 1 minus cos squared theta. Okay, so I'm plugging this in for this. Okay. All right, so that gives us cos squared theta minus bracket 1 minus cos squared theta. Now we have to distribute the negative 1 into both parts. Okay. So we get cos squared theta minus 1 plus cos squared theta. And now if we collect like terms, I notice I have 2 of these guys. Okay, remember they're being added, not multiplied. So that means my other version for cos 2 theta is 2 sets of cos squared theta minus 1. Okay, so that's version number 2. All right, and our last variation, we're going to go with the same. We're still going to work with this version here in purple. And this time we're going to replace the opposite. So now we're going to replace cos squared theta with the Pythagorean identity rearrangement, okay, with 1 minus sine squared theta. So let's see what that one looks like. So remember, now you're replacing this guy. So 1 minus sine squared theta minus sine squared theta. Okay, so in this case here, no negative is being multiplied in, so we can actually just drop the brackets here. You're going to be left with 1, and then we're going to collect like terms here. So we're going to have minus 2 sine squared theta. And that is our third and final variation of cos 2 theta. Okay, so 1 minus 2 sine squared theta, 2 cos squared theta minus 1. Okay, be very careful with this. Make sure you have it in the right order. So in this term here is negative, the 1 is positive. In this variation, this term is positive, also with a different function, and then the 1 is negative. So be very careful with that. Okay. All right, and tan 2 theta, let's do the same thing there. So let's do the, rewrite it as tan theta plus theta. Okay. And again, this to us should look like tan A plus B, where A is theta and B is theta. So that should look like tan theta plus tan theta divided by 1 minus tan theta times tan theta. So we're going to collect the 2 terms up top. So that's 2 tan theta, and then these 2 multiplied will give us tan squared theta. So again, just one variation for this one. So tan 2 theta is equal to 2 tan theta, 1 minus tan squared theta. Again, All these are nice because it makes the k value 1 for all the trig expressions on the right side. Okay, so let's do some practice working with these. Just keep in mind, just like with compound angle formulas, the double angle formulas are used to simplify trig expressions and determine exact values of trig ratios. Okay, so let's just get, for now, practice recognizing the formulas and expressing each of these as a single trig expression. So for these examples here, they're all going to appear in their right side versions. Okay, a little bit, and we want to go backwards and write it as a singular term. So notice in these versions here, these are two terms, two terms, two terms. So when I say write it as a single expression, that means I want it combined. So I want you to write it like it is on the left side. Okay. All right. So here we have negative sine squared x plus cos squared x. So one thing you can do is you can just rearrange this. So for example, put this guy first and this guy second. Make sure you leave the negative with the appropriate term, okay? So that becomes cos squared x minus sine squared x. And you should be thinking, okay, that looks familiar, okay? Getting used to this. That's equivalent to cos 2x, right? And in our example, they're using x. In this example, they were using theta. Okay, so this is equivalent to cos 2x. Okay, so we just wrote this expression as a single trig expression. Right, so all right, this one here. So it says 2 tan 4x divided by 1 minus tan squared 4x. So right away, I'm looking at this and I'm looking at this, right? And I'm thinking that they look similar, okay? So I'm saying it looks like tan 2 theta, but what has been replaced, right? So it looks like instead of where theta should be, there's a 4x. So it looks like tan 2 theta where theta is 4x, okay? So let's work backwards then. So if this is theta 4x, then that means this is equal to tan 2 bracket, and then wherever I see theta, I'm putting 4x. Right? So this looks like tan 2 theta, where theta is 4x. So now obviously you should always simplify here. 2 times 4x is another way of me writing tan 8x. Okay. So we just wrote this as a single trig expression. Because here this was a trig expression up top, and then 1 minus, and then another expression here at the bottom. So this collectively put it as 1. All right, let's turn over. Now let's simplify each of the following expressions. Okay, so very similar to what we were just doing before. And then we're going to evaluate. So now we're going to see how it's helpful to simplify first and then evaluate. So for example, and also you can draw your special triangles at the top here. This is going to be helpful for us when we have to evaluate for exact values. So draw those in. So step 1 I have here in purple, we're going to simplify. Step 2 we're going to evaluate. So this expression here, we have 2 sine pi over 8 cos pi over 8. This expression we could not do without the use of a calculator, okay? Because we're not used to the angle pi over 8. Okay, if we needed without a calculator, it would have to be our special angles. So with pi over 8, you're going to see how we can solve this now with our new formula. So right away you should be saying, okay, this looks like 2 sine theta cos theta. Okay, so remember you should be looking back to the new formulas we just got. So 2 sine theta cos theta is just another way of saying sine 2 theta. Okay, remember sine 2 theta became this. But obviously in this case here, the theta is pi over 8. Okay. All right, so let's replace it. Let's write it as a single term. So this is the same thing as sine of 2, and then remember 2 times theta, so 2 times pi over 8. That simplifies to sine pi over 4. There we go, we're done step 1. Okay. Do we know how to evaluate sine pi over 4 without a calculator? Yes, we do, because that's a special angle. So now we're going to evaluate. We're going to go to sine pi over 4, which is here, and we're going to do opposite over hypotenuse. So that's 1 over root 2, and we know that when we rationalize the denominator, that's just root 2 over 2. So there we go. We solved this without a calculator, even though at first glance those angles were not something we could work with. All right, part B. So notice with part B, we've got tan pi over 6, right? And both here, and then here it's tan pi over 6 all squared. So technically, we could go about simplifying this without a calculator because it works with pi over 6. But I'm going to show you another way of solving it that will make it a little different, so that we use our double angle formula, simplify it first, and then evaluate. So right away, you should be saying, okay, that this looks like tan 2 theta. Obviously, though, where the theta is pi over 6. Okay, so that's normally a theta here, so theta is pi over 6. So let's plug that in, okay? So I'm going to rewrite this as tan bracket 2 times pi over 6. Simplified, that's tan pi over 3. Okay, right? 2 pi over 6 reduces to 1 pi over 3. That's as simplified as it's going to get. And now we're going to evaluate. This is a special angle, so we're going to go up here. Tan of pi over 3 is opposite over adjacent, so that's root 3 over 1, so just root 3. And that is how you simplify and evaluate expressions that either look really complicated or that have angle measures we can't use without a calculator, and this is how you do it. All right, let's try the next question. It says express 1 minus 2 sine 3 pi over 8 squared, okay, as a single trig ratio, and then evaluate. So very similar to what we did up here. Okay, so looking at this, we should be saying that this looks like, 1 minus 2 sine squared theta, which we know is equivalent to cos 2 theta. Okay, but obviously here, the theta value has been replaced with 3 pi over 8. So remember, this is just one of 3 variations of cos 2 theta. So you have to be able to recognize all 3 of them. All right, so let's replace it then. So if this is cos 2 theta, where theta is 3 pi over 8, we're going to do cos of 2 times 3 pi over 8. Okay. When we do some canceling in lowest terms, right, you're going to get 6 pi over 8, which will reduce to 3 pi over 4. Okay, so that's simplified as a single trig ratio. Okay. You have to do this first, okay? That's the whole point. So when I write that, make sure you do that before just plugging into your calculator. Okay, a lot of this is so that we can evaluate without the use of a calculator. So cos 3 pi over 4. So I know up here we were able to get an answer right away, and the reason for that was because these were all angles that were acute, so meaning that they all landed in quadrant 1. When they're acute angles, we can just simply use the special triangles, right? Because we know that all sine, cos, and tan ratios are positive with acute angles. However, this one's going to involve more work. And this is the step I think students forget the most, is that they forget to go back to the basics of Unit 6. So if I give you cos 3 pi over 4, okay, that is not an acute angle. Okay, that's 3 sets of 45. So we have to go back and do what we did last unit. How do we find this value? Okay, so step 1. You visualize the graph to see what quadrant it lands in. Okay, so 3 pi over 4, that'd be 3 sets of 45. So 1, 2, and 3, landing right here with the purple. Okay, so it lands in quadrant 2. Okay. All right, we need to find beta. Okay, beta you can do by doing pi minus 3 pi over 4, or you can just look at the fact that it's 3 sets of pi over 4 and know that that's beta. Okay, you're going to draw out your special triangle, okay, and then we're going to do cos of beta, which is cos pi over 4, so that's opposite over hypotenuse. Okay, so that's 1 over root 2, and when we rationalize the denominator, root 2 over 2. And lastly, we have to analyze the cast rule. Okay, so cos theta, based on cast rule, so I'm going to draw it in here. C-A-S-T. So cos is negative in this quadrant, so that means the value of cos 3 pi over 4 is going to be negative root 2 over 2. Okay. So all this same side work that we do, and that's why understanding everything from Unit 6 will make all this easier. Okay. So our final answer is that this expression that we would not have been able to calculate without using a calculator before our knowledge of this lesson, we were able to do without ever punching that into a calculator. So we were never used to 3 pi over 8, but when we use the double angle formula, it gives us an angle we can evaluate with exact values on our own, and there we did it, negative root 2 over 2. Okay, our next example says, and these types of examples, we kind of did it on the previous lesson, and these ones are always going to come up as well. So it says, given sine theta equals 5 over 13, and that theta is between pi over 2 and pi. So between pi over 2 and pi is quadrant 2. Okay, so I'll just do a little sketch here, right? So this is pi over 2, this is pi. Okay, so they're basically saying it lands in quadrant 2 only. Okay, so all these are kind of not options. Okay, so it lands here. It says evaluate sine 2 theta, cos 2 theta, and tan 2 theta. All right, so we have to evaluate all these by only being given the ratio for sine theta. So let's just start, and we know sine theta is opposite over hypotenuse, so we know we have those two values of the right triangle that would be created, and we know it's in quadrant 2, so that's important as well. So let's start with sine 2 theta. There's only one version of sine 2 theta formula, right? And we know that that is 2 sine theta cos theta. So now we're going to fill in what we know. We know sine theta has a value of 5 over 13, so we're going to plug that in. Okay. Right, so we plugged in this for here. However, the question did not give us cos theta. So that means you have to go somewhere else on your page and you have to do some side work. We're going to have to do some work here. All right, so let's come down here. We are on a mission to find cos theta, which we know is equivalent to x over r. So this is what we know. So what I have here in green is what we were given. We were given that sine theta is 5 over 13. Okay, so we know sine is equivalent to y over r. So they gave us a y value of 5, positive 5, and an r value of positive 13. R is always positive as well. So on first glance, you would be saying to yourself, well, if sine is positive, it can be in quadrant 1 or 2. But because the question specified quadrant 2, that's very important you read that, or else you are going to get their incorrect values. So I know it's going to land over here like I've drawn in blue. Okay, I want you to draw your angle. I want you to draw your right triangle that's made, okay, and label what you know. So we know y is 5, so I put 5 on the vertical part. The hypotenuse here is 13, the radius. And x is the value we do not know, and we need x in order to find cos theta. So let's use Pythagorean theorem to solve for x. Okay. So x squared is equal to r squared minus y squared, because we're solving for one of the legs of the triangle, so it's always r squared minus the other leg squared. So 13 squared minus 5 squared, 169 minus 25. Okay, so that gives us x squared equals 144. Okay, and we're going to do our square root of both sides. Okay, and that will give us x equals plus or minus 12, right? That's the proper mathematical answer. But then you have to do some thinking. Because the angle over here would create a triangle whose x value would be on the left of 0, that means that the x value would have to be negative. So we have concluded that the final answer has to be that x equals negative 12 since theta is in quadrant 2. Okay, so we basically had to choose this answer. Oh, my apologies, circled the wrong one. Has to be the negative. So that's why knowing what quadrant it is very important, or else you might have picked the positive if you drew it in this quadrant over here. Okay. All right, so that means that we can answer x over r. So now we know cos theta is equal to negative 12 over the r value of 13. All right. Another common mistake students do, and I see it every year, is that they will go back and put negative 12 over 13 in for just theta. So they will write cos bracket negative 12 over 13. Whatever you need to do, write on a separate sheet of paper, put on a post-it note, write that that is not the case. Okay, negative 12 over 13 is not an angle measure, right? Theta is an angle measure, and we did not solve for theta, we solved for cos theta. We solved for what the ratio of this angle was in terms of adjacent over hypotenuse. So this fraction value we get is all cos theta. Okay, so it is not what you sub in for theta value, and if you need to put that somewhere, please do. All right, so when we plug that in, so like I said, cos theta is negative 12 over 13. So remember, multiply the numerators, multiply the denominators. There's an imaginary denominator here of 1. So 2 times 5 times negative 12, all divided by 1 times 13 times 13. And you are going to get this lovely number, negative 120 over 169. Okay, and obviously always simplify to lowest terms, and that is in lowest terms. Again, you should be impressed with yourself. You just calculated what looked very ugly at first without ever using a calculator, right? We didn't have to go in and punch that into a calculator here, or we didn't have to solve for theta in order to find it as well. All right, let's move on to cos 2 theta. What's interesting about cos 2 theta is that you have 3 different variations of formulas to work with. So you are not wrong depending on what you choose to work with. Sometimes you might want to work with the one that you have the most information for. So for example, if I had given you this question without asking you to do this part, so maybe I didn't ask for sine 2 theta. So say I just gave you this. In my mind, I always want to do the least amount of work possible, right? We all want to do that. So I would have chosen this version of cos 2 theta, 1 minus 2 sine squared theta, because it would have meant that I didn't have to do any other calculations, because technically I already know sine theta, so I can just plug it in and square it. Okay. If I used the other 2 variations of cos 2 theta, those both involve knowing what cos theta is. Okay, so that would have involved more work. In this scenario here, you already did the work for cos theta, so you can honestly choose whatever formula you want. Okay, I am just going to go along with this one. Okay, so that's 1 minus, remember I'm rewriting it as just sine theta squared. If that helps you, please do so. So that is going to give us 1 minus 2 times, and then remember that's 5 over 13. 5 over 13 all squared. So that's 1 minus 2 times 25 over 169. Okay. So that's going to give us 1 minus, and then you multiply the numerators here, multiply the denominators. Remember the imaginary denominator here is a 1 underneath the 2. Okay. So 1 minus 50 over 169. We want to find a common denominator of 169, so multiply top and bottom of the 1 here. So we get 169 minus 50 divided by 169. And that simplifies to 119 divided by 169. And that is the value of cos 2 theta. And we were able to do that by knowing one ratio, right, where theta, where the k value was 1, and we actually never had to solve for theta. All right, and lastly, let's do tan 2 theta. So, let's move that. So in this one here, when we find tan 2 theta, this is our formula, okay? Again, writing it without the 2 in there means we can just have a tan theta and a tan theta squared, which means that we know how to work with something with a k value of 1 based on what we've been given here with a k value of 1. So we know tan theta is y over x, and we've already done the work from part A, so we have everything we need. So y over x is going to be, okay, so the y value is 5, and the x value is negative 12. So 5 over negative 12, and obviously math in proper form, you bring the negative to the top, okay, because this just looks bad, and you write it as negative 5 over 12. All right, so we're going to plug negative 5 over 12 in for tan theta. Remember, it's tan theta altogether. All right, so I did some colors here because I know it looks kind of crazy with the numerator and the denominator with fractions within them. So 2 times negative 5 over 12 is in blue, okay, and I've just, the numerator's in blue here, divided by 1 minus negative 5 over 12 all squared. Okay. So up top here, I immediately, since I'm multiplying, I know I can start doing some canceling. So this is, the numerator is going to simplify to negative 5 over 6. The denominator, you're going to do 1 minus, and then you have to square the top and the bottom here. So negative 5 squared and 12 squared. Okay, so we're going to get 1 minus 25 divided by 144. In order to simplify the bottom, the denominator, we are going to have to find a common denominator of 144. So multiply the top and bottom of 1 there. Okay. So we're going to get negative 5 over 6 divided by 144 minus 25 divided by 144. So we get negative 5 over 6 divided by 119 over 44. So a fraction divided by a fraction means that you keep the top fraction the same, flip to multiplication, and so multiply by the reciprocal of the bottom. So negative 5 over 6 times 144 over 119. That gives us negative 720 over 714. And then in lowest terms, that's negative 120 over 119. And those are your, and that is your final answer for what the value of tan 2 theta is. So we took an expression that had a k value of 2, and we converted it to its equivalent expression, its formula, with a k value of 1, and then used this information to find that exact value. All right, and let's try our last example here. Very similar idea. So it says cos theta is equal to negative 2 over 3. So again, they've given us the ratio of adjacent, right? So they gave us here adjacent over hypotenuse. Okay, so here in the last example they gave us a certain quadrant. Here they kind of gave us, they opened it up to all 4. So it says theta is between 0 and 2 pi. So this could be any of the 4 quadrants. And it says determine the value of cos 2 theta and sine 2 theta. All right, so let's start with cos 2 theta. Again, you can, like I said, you can use any variation of the formula, but I am personally going to try to use the one that means I don't have to do as many calculations at this point. So I'm going to use the variation of cos 2 theta that only involves cos because I've been given cos theta. So I'm going to use this one. I'm going to use that it equals 2 cos squared theta minus 1, because then I can just sub in cos theta. The other two variations involve sine theta. All right, so let's plug in what I know. So remember, this is just rewrite it as 2 cos theta squared minus 1. I know what cos theta is equal to. It's equal to -2/3. Okay, so that's its ratio of its adjacent and hypotenuse. So I'm going to plug that in. Okay, so cos theta right here. So we're going to do 2 times -2/3 squared minus 1. Remember, do your exponents first. -2 squared is 4, 3 squared is 9. And it doesn't matter, even if you had put the negative with the bottom, it would still give you the same answer, right? Any negative squared will be positive. Now we follow BEDMAS. We're going to do a multiplication. So we get 8/9 minus 1. Now we have to write it as one expression. Okay? So multiply top and bottom by 9 to find the lowest common denominator. And we get a final answer of, so 8 minus 9/9 will give us -1/9. And that's the value of cos 2 theta. All right. Now we're going to do sine 2 theta. So sine 2 theta, if you're only given one trig expression, sine 2 theta is always, you always know you're going to have to find the other trig ratio. Unless they gave you both, because sine 2 theta's only equivalent expression is 2 sine theta cos theta. Okay, so you're kind of stuck with both of them no matter what. So here, again, the only thing we know is this guy. We only know cos theta. So I'm going to rewrite this as 2 sine theta times -2/3. So we are going to have to find what sine theta is. So even though we try to keep ourselves from work here, unfortunately the second part of the question still means we have to find sine theta, okay? But you never know, some of the questions you want to limit the amount of work you do, so always kind of think of that. All right, so at this side here, I'm thinking, in order to find sine theta, I need to do my drawings like I did in the previous example. But what's troublesome here is that this time I have no idea what quadrants it's in specifically. So all they did was tell me that cos theta was negative and that it could be anywhere from quadrant 1, 2, 3, or 4, right? So one cycle. So if cos theta is negative, and I haven't been told anything else other than that's between 0 and 2 pi, that means I have to use my cast rule. Okay, so cos is negative in quadrants 2 and 3. So that's very important. So cos theta is negative in quadrant 2 or 3. Unfortunately for us, that means that we have to do more work. So because I have no idea which one it is, I have to come up with a solution for if it was in quadrant 2 and come up with a sine 2 theta solution if it was in quadrant 3. Okay, so lots of work here, but the steps should be repetitive, so it's just more tedious than anything. So let's do case number 1, and that's where theta lands in quadrant 2. Okay, so let's draw that. So now we're imagining that it lands in quadrant 2, so draw your theta. Remember, work with what you've been given. They told you cos theta is -2/3. So the r value, remember, radius is always positive, so that's the 3. And the x is -2. Yeah, that makes sense because the arm's extending to the left side of 0. So we have our triangle here. Okay, so our right triangle. All right, so we have this, we don't have y, and we need y in order to find sine theta because sine theta is y/r. All right, so let's do some calculating. So we're solving for a leg of the triangle, so that means we're going to work with y squared equals r squared minus x squared. Right. So that is going to be 3 squared minus -2 squared. So that's 9 minus +4. So y squared equals 5. Okay. So mathematically, when we take the square root of both sides, right, that means y is equal to plus or minus root 5. Okay, always leave it as the simplified radical. So now you have to think to yourself, why did we choose the positive version? Okay, so I'm circling that. We chose positive root 5 because the angle measure here, if I were to find a point on it, the y value is going above the x-axis, so that means it would have a positive y coordinate. So y is positive root 5 in quadrant 2. So that means that if sine theta is equal to y over r, then sine theta is equal to positive root 5 over 3. So that's sine theta in this quadrant. Okay, so let's come over here and use that here. So, okay. All right, so sine 2 theta, let's review the formula. So remember, the formula I'm picking up from is here, okay, maintained in the purple. So that would be 2 times, and then sine theta in this scenario is root 5 over 3. So times root 5 over 3 times negative 2 over 3. Okay, so that would give us 2 times negative 2 times root 5, so that's negative 4 root 5 over 3 times 3, and then the imaginary 1 here, so over 9. Okay. So this is one of my first answers. Okay, so this is one possible answer for sine 2 theta in this question. Okay, that's one possible answer here. All right, that was if it landed in quadrant 2. So now we're going to do this if it lands in quadrant 3. Okay, so case 2 is when theta is in quadrant 3. So again, I want you to draw your angle here. Okay, I always want you to include sketches, so I make sure you are actually understanding the scenario. So this is, it lands in somewhere in quadrant 3. This is the same information. I still know x and r. So this is my x here, negative 2 in the triangle. I don't know my y value, and my r value is still 3. So it should be that same process. Okay, so where you're solving for y, it should be the same calculation as in case 1. Okay, so all the same process where y squared equals 5 and then y equals plus or minus 5. However, this time you have to be thinking about this value here. Okay, so again, we're still square rooting here. Because now the y value, or this line, extends below the x-axis, that means the y value is now negative. So in this scenario, y is negative root 5. Okay. So if sine theta is equal to y over r, that means in this case, sine theta is equal to negative root 5 over 3. Okay. So this was very important because this one here is a different value than this here. Okay. So we're going to take this, okay, do the same thing we just did. So sine 2 theta in this scenario is 2 times negative root 5 over 3 times, and then that's still staying negative 2 over 3 here. So up here, when we multiply, the two negatives will become a positive, so we're going to get positive 4 root 5 divided by 9. So that's our second answer. Notice that they were the same absolute values, obviously just both of them different signs. So when you give me your final therefore statement, the proper answer for what is the value of sine 2 theta, so you're going to say sine 2 theta is equal to, and then you're going to state both, plus or minus 4 root 5 over 9, depending on the quadrant. All right, that is everything with double angle formulas. Not too many homework questions here at the bottom. Good luck with the homework, and let me know if you have any questions.